Imagine yourself on a perfect beach in Thailand. Powdery white sand tickles your feet. Turquoise water lazily laps at the shore, and the sweltering air smells of salt and coconut oil. The day seems flawless. But suddenly you notice something strange, a disruption in this perfect rhythm. Birds burst from the palm trees with piercing, panicked cries, flying inland away from the water. A herd of elephants, which had just been entertaining tourists, begins to trumpet deafeningly, snapping their thick chains and rushing for the hills. Dogs, with their tails tucked, whimper and press themselves to the ground, their bodies trembling, refusing to go near the ocean. A silent, instinctive panic unfolds around you. A panic whose cause you cannot see, hear, or even imagine. This is the morning of December 26th, 2004. In an hour, a giant tsunami wave in the Indian Ocean will crash ashore, claiming the lives of 230,000 people. But when rescuers begin to clear the debris among the wreckage of hotels and homes, they will encounter a stunning, almost mystical mystery. Among the countless human casualties, there will be almost no bodies of wild animals. They left. They knew. How? Our sophisticated, multi-million-dollar satellite systems, our ultra-sensitive seismic stations, they all remained silent until the moment of impact. But the elephants, birds, and even the toads received a warning. They heard the symphony of destruction to which our technologically advanced species was completely deaf. This isn't mysticism. It's physics, biology, and geochemistry. What we call the sixth sense in animals is actually a set of at least 4 real, measurable, physical mechanisms. By the end of this story, you will understand how animals can feel the subtle tremors of the earth minutes before we do. How they hear the silent, infrasonic roar of the planet from hundreds of miles away. And how scientists, like ornithologist Martin Wikelski, are right now trying to crack this ancient code of nature with the ICARUS project, aiming to transform animals into a global network of living sensors, a true Internet of Animals, a system that could one day save millions of human lives. But this mystery is as old as history itself. Let's travel back to 373 BC, to the ancient Greek city of Helike, a prosperous city-state. The air smells of wine and olive oil. A few days before the catastrophe, its inhabitants witnessed an inexplicable, disturbing exodus. Snakes, weasels, centipedes, and rats. All the creatures that hid in cool cellars and earthen burrows suddenly abandoned the city en masse, creating living streams flowing toward the mountains. The people watched them go, bewildered. And then the earth shuddered, and the city of Helike was forever submerged beneath the salt waters of the Corinthian Gulf. This is one of the first written accounts, recorded by the Roman historian Aelian testifying to the fact that animals know. Ancient myths? No. This is a historical pattern confirmed in the 20th century. The most striking example, 1975, the Chinese city of Haicheng. Picture a freezing winter. Snakes suddenly crawl out of their burrows and freeze to death on the snow. This is certain death, a violation of every survival instinct. Livestock thrash in their pens, refusing to eat. Chinese authorities, unlike the ancient Greeks, heeded these thousands of anomalous signals. They issued an unprecedented order: evacuate the city of 1 million people. A few hours later, a massive 7.3 magnitude earthquake reduced Haicheng to ruins. This is the only time in history that a mass evacuation was ordered based solely on animal behavior. Tens of thousands of lives were saved, but it was the 2004 tsunami that forced the world to take this seriously. Because it wasn't just one city. This involved the coastlines of 14 countries bordering the Indian Ocean. And everywhere, from Indonesia to Sri Lanka, eyewitnesses told the same story. Flamingos suddenly flew away from low-lying breeding grounds. Buffalo, sensing trouble, moved to higher ground. Pet dogs refused to go for their morning walks on the beach. The scale of the tragedy and the scale of the almost miraculous, widespread survival of animals proved that this could not be a series of coincidences. It is a global phenomenon, and it demands a scientific explanation. History is filled with such accounts. For thousands of years, we observed these strange flights, but dismissed them as superstition. How do they do it? How do they receive a signal, minutes, hours, or even days before a disaster? The first key to the mystery lies right beneath your feet. Its vibration, a tremor in the Earth's crust that you are unable to feel, but which to them is like an alarm bell. Imagine a typical evening. You're sitting in your living room, the warm glow of a lamp filling the room, when suddenly your dog lets out a low, guttural howl. She paces frantically, her claws scraping against the floor, scratching at the door, trying to get out. You don't understand what's happening. The house is completely silent. Everything outside is calm. But the animal is gripped by a primal, inexplicable terror. A minute later, the floor beneath your feet begins to vibrate. Books fall from the shelves with a clatter. Dishes in the kitchen rattle and break. An earthquake is starting. The dog knew. A minute before you did. Her secret lies in the physics of seismic waves. Every earthquake generates two types of waves. First are the P waves, or primary waves. This is the first whisper of the catastrophe. They travel at the speed of sound through rock. They are very fast, but weak. They don't cause destruction, only a light, barely perceptible high-frequency vibration. Second are the S waves, or secondary waves. This is the deafening scream. They are slower, but they carry the destructive power, shaking the ground from side to side. Our senses are too crude to perceive the initial whisper of P waves. We only feel the devastating impact of the S waves. But animals whose paws are firmly on the ground pick up that very first tremor. For them, it is an unmistakable alarm signal. But this explanation has a strict limitation. P waves arrive only a few seconds, or at most a couple of minutes, before the main shock. This perfectly explains the dog's panic in the living room, but it in no way explains the behavior of the animals in Thailand, who began their evacuation an hour before the tsunami. And it certainly doesn't explain the exodus of snakes and weasels from Helike days before its destruction. They needed another signal, an earlier one, more powerful, and coming from a much greater distance. To get a warning hours or days in advance, you need more than just feel. You need to hear. To hear a roar that is silent to us, but deafening to them, with which the planet itself announces an impending cataclysm. Let's go back to those elephants on the coast. Eyewitnesses say it wasn't blind panic. It was an organized retreat. The animals made deep, trumpeting sounds that vibrated through the ground itself. They turned to face the ocean, where a deceptive calm still reigned, and stubbornly pulled their handlers away from the water, up the slope. Imagine the scene. The huge elephant you are riding on suddenly ignores all commands. It is saving your life, carrying you to the safety of high ground an hour before a wall of water crashes ashore. They weren't just fleeing. They clearly heard the order to retreat. The source of this command is infrasound, sound waves, with a frequency below 20 Hz. This is below the threshold of your hearing. Like a bass note, so low, you can no longer hear it, but only feel it in your chest. Such waves are generated by the most powerful forces on the planet: volcanic eruptions, hurricanes, and, of course, the friction of giant tectonic plates on the ocean floor. Infrasound hardly dissipates in water and earth. It travels for hundreds, even thousands of miles. We don't hear it. But elephants, whales, alligators, and other large animals detect these vibrations, not just with their ears, but with their bones, with their entire bodies. For them, it's not just noise. It is the language of the planet itself, speaking at frequencies completely inaccessible to us. The 9.1 magnitude earthquake that caused the tsunami occurred hundreds of miles from Thailand. For any person on that perfect beach, there was an idyllic silence. You would have heard only the lazy splash of waves and the cries of gulls. But for an elephant, it was a deafening, growing roar. The roar of an approaching catastrophe, which it felt in every bone of its enormous body. They heard the tectonic plates grinding against each other deep under the water. They heard the multi-mile-high column of water begin to move long before it could be seen. Infrasound perfectly explains the reaction of the giants. They hear the storm over the horizon. But what about the birds that take flight days before a hurricane, or the fish that suddenly retreat to the depths? Their secret lies elsewhere, in an invisible force that permeates the entire planet, by which they calibrate their internal compass. A force that starts to go haywire before a disaster. A few hours before impact, the sky turns into visual chaos. Imagine huge flocks of migratory birds flying south suddenly break formation. They scatter. They fly in the opposite direction, north into the cold. City pigeons become disoriented. They circle in place as if drunk and crash into glass storefronts. Their internal compass, which flawlessly guides them across continents along invisible magnetic lines, has simply been fried by interference. For them, their entire world has gone askew. This compass is their sensitivity to the Earth's magnetic field. And it is not static. Scientists have discovered that before an earthquake, colossal pressure builds up in the Earth's crust. Imagine squeezing a sugar cube in your fist until it starts to crack. In the same way, tectonic plates squeeze quartz-rich rocks. And under pressure, these rocks literally scream with electricity. They generate powerful, local electromagnetic fields. This creates anomalies, real magnetic storms right at the Earth's surface. For a bird navigating by invisible field lines, this is a catastrophe. Its map of the world is suddenly covered in blind spots and false routes. But that's not all. One of the first to crack this code was physicist Helmut Trebuch. Back in the 1980s, he realized it wasn't just about navigation. It was about biochemistry. His theory, the compressed rocks don't just create fields. They release billions of positively charged ions into the air. This invisible ionic wind changes the electricity in the atmosphere. It induces in animals, and even in some humans, what doctors call serotonin syndrome. A sharp headache, nausea, a bout of baseless, animalistic panic. You don't just see a broken compass. You physically feel the approaching doom, just as we feel the heavy, oppressive humidity in the air right before a lightning strike. So, we have three keys: the tremor of the earth, felt by paws, the roar of the planet, heard by bones, and the broken compass, driving them mad. All of this provides a warning minutes or hours in advance. But the most stunning proof came not from the skies or the ocean depths. It came from an ordinary muddy pond in Italy. And it gave a precise warning a full 5 days before the disaster. At a time when all seismologists' instruments showed absolute silence. The year is 2009. The quiet, sun-drenched town of L'Aquila in central Italy. Here a group of biologists led by Dr. Rachel Grant is conducting a routine, almost meditative study. They are observing a local colony of toads. Every day, they visit a small pond and meticulously keep records. But one day in late March, they encounter an anomaly. The pond is unnaturally quiet. The water is still. All the toads, every single one, hundreds of amphibians, had simply vanished. The scientists are completely baffled. The breeding season is in full swing. Abandoning their spawn is a direct violation of their basic instinct. They search the surroundings, hypothesizing about predators or local pollution, but find no clues. 5 days later, the answer arrived with a deafening roar from beneath the earth. The city of L'Aquila was wiped off the face of the earth by a 6.3 magnitude earthquake. It was reduced to ruins in 32 seconds. What the toads felt was not a tremor. It was not a low-frequency hum. It was a chemical taste, the acrid smell of impending death. Before an earthquake, colossal tectonic pressure literally squeezes volatile chemical compounds out of deep rock layers. Radioactive gases like radon begin to seep from microcracks in the crust. Streams of ions are released into the groundwater, drastically changing its chemical composition. To our crude sense of smell, these changes are completely unnoticeable. But for amphibians, who breathe through their permeable skin and live in water, it's like being in a bathtub full of acid. Their home, their cradle, suddenly becomes toxic, and the only instinct they have left is to flee. And here is the most astonishing detail recorded in Dr. Grant's report. A full 5 days before the catastrophe, 96% of the entire observed toad population had abandoned their breeding grounds. 96%. At that very same time, the needles of local seismographs remained motionless. People continued their daily lives, unaware of the tension building beneath their feet. But the small, primitive creatures already knew their world was doomed. This study became one of the most compelling pieces of scientific evidence. So, we have 4 completely different physical signals: the imperceptible tremor of primary waves, the inaudible infrasonic roar of tectonic plates, the invisible fluctuations of the planet's magnetic cocoon, and the toxic, ionized breath of the Earth's interior. Animals are millions of living, organic sensors scattered across the planet, each perfectly calibrated to its own frequency of threat. But how can we unite all these disparate biological signals into a single global warning system? How do we turn a chaotic chorus of panic into a clear alarm? One man decided the answer should be sought not on the ground, but 400 kilometers above it, in low Earth orbit. Meet Martin Wikelski, an ornithologist, a researcher, and the director of the Max Planck Institute of Animal Behavior. But above all, a visionary. A man who looks at a flock of birds and sees not chaos, but a highly complex information network. For his entire life, Wikelski has been obsessed with an idea that his colleagues at scientific conferences considered science fiction at best. He wanted to create an Internet of Animals, a global network that would allow us to see the world through the eyes of its inhabitants in real time. For decades, he was met with cold smirks and the rustle of disapproving peer reviews. But Wikelski believed that if we could learn to listen to animals through the language of data, they could warn us about things we cannot see or hear ourselves. His dream was given a name: ICARUS, or International Cooperation for Animal Research Using Space. Here's how it works. Thousands of animals around the world, from storks in Europe to bats in Panama, are fitted with tiny transmitters. Each tag weighs just 5 grams. It's a miniature high-tech backpack, but inside it contains a high-precision GPS, an accelerometer, a magnetometer, and a solar battery. These beacons transmit a continuous stream of telemetry around the clock, location, speed, altitude, and even the animal's body temperature. All this information is collected by a special antenna on the exterior of the Zvezda module on the International Space Station. Flying over the planet at 28,000 kilometers per hour, the ISS polls thousands of living sensors, creating an unprecedented picture of life on Earth. The goal is to find anomalies, to pinpoint the moment when thousands of animals suddenly take flight for no apparent reason, transforming into a living early warning system. But this beautiful idea has a powerful, cold adversary: scientific skepticism. For years, the geological community has maintained the same position. All of this is nothing more than a collection of anecdotal evidence and random coincidences. Yes, animals sometimes behave strangely before an earthquake, but they also behave strangely for 1,000 other reasons. The sharp scent of a predator in the air, panic. The icy breath of an approaching storm, panic. An internal fever from an illness, panic. How can one be distinguished from the other? Scientists demand rigorous, reproducible evidence, a reliable, predictive model that works every time, not just occasionally. Without it, they argue, all the stories about a sixth sense are just folklore. This is a fundamental clash of two worlds, a battle between living instinct and silicon algorithms. On one side of the scale is the ancient intuition of nature and millennia of observations recorded in chronicles. On the other is the cold, rigorous logic of science and its demand for 100% accuracy here and now. And this brings us to the biggest, most complex problem of the entire phenomenon, to its Achilles heel, to the question that prevents this amazing ability from becoming a reliable tool for saving human lives. Imagine this scenario. Authorities in a seismically active region receive data from the ICARUS project. Thousands of birds have suddenly changed their routes. Goats on mountain pastures are panicking, huddling together in tight herds. The sensors show unprecedented anomalous activity. The government makes a difficult decision: to order the evacuation of a city of 1 million people. The piercing wail of sirens shatters the morning silence. People hastily abandon their homes. A day passes. 2. A week. But the earthquake never comes. The economy is paralyzed. billions of dollars are lost. And more importantly, public trust is eroded. The next time the animals sound the alarm, will anyone listen? This is the main limitation. We cannot yet distinguish a distress signal from the background noise of animal life with 100% certainty. Scientists call this the problem of false positives. It's like trying to hear one person's whisper in a crowded stadium. Animals might be reacting to an approaching predator, a sharp change in atmospheric pressure, a food shortage, or a virus within the herd. Their world is full of threats, and an earthquake is just one, and a relatively rare one at that. Until we learn to flawlessly isolate the specific geophysical signal, the animal's sixth sense remains an incredibly interesting phenomenon, but an unreliable oracle, an oracle that is dangerous because of its unfulfilled prophecies. This is why the goal of the ICARUS project has shifted. It was a key pivot from attempting precise prediction to a strategy of probability assessment. The idea is no longer to replace seismographs with animals, but to supplement them. Imagine not a red evacuate button, but rather a yellow traffic light. When data from animals shows an anomaly, it's not a command to flee. It's a signal for authorities. Attention! There is an elevated risk in your region for the next 48 hours. Increase the readiness of emergency services. Check your warning systems. It's not about predicting the exact time, but about defining a window of danger, which transforms the panic of animals from the curse of false alarms into a priceless resource. We have journeyed from stories recorded on dusty scrolls to a stream of digital data from the International Space Station. We have dissected the 4 physical mechanisms that underlie this marvel. And in the end, we have understood. Animals do not predict the future. Their gift is an absolute, unfiltered sensitivity to the pulse of the planet in real time. A pulse we have learned to ignore. So what does all this mean for us? And what should we really be learning from them? Let's put it all together. It's not some mystical sixth sense. It is our ordinary 5 senses, simply honed by millions of years of evolution to an unimaginable degree of perfection. It is hearing, for which the rumble of colliding continents is not a metaphor, but a real, deafening, infrasonic roar. It is touch, which feels the primary P waves through the pads of paws, a tremor racing across the planet at 8 kilometers per second. It is your internal compass, magnetoreception, reacting to the slightest fluctuations in the Earth's protective field like a needle that has gone haywire. And it is a sense of smell, capable of detecting the subtle, alarming note of ionized air in the scent of damp earth. Animals possess no magic. They simply never stopped listening to the language the planet itself speaks, the language of physics, chemistry, and vibrations, which we have long forgotten how to understand. Martin Wikelski and his ICARUS project are not just an attempt to predict disasters. It is something much greater. It is an act of technological humility, a desperate attempt by humanity to create a high-tech hearing aid for itself, an admission that in our quest to conquer nature, we have become completely deaf to it. We have surrounded ourselves with concrete and asphalt, creating an acoustic shadow where the whispers of the earth are drowned out by the roar of traffic and power grids. Wikelski's goal is not to prove that animals are oracles. His goal is to use our best technology so that we can once again learn to hear what has always been there, to reclaim a lost sense of connection to the world we live in. After all, the key to saving thousands of lives may not be encrypted in more complex computers, but in the panicked flight of an ordinary bird above your head. And perhaps the greatest paradox in this whole story is not why animals sense approaching disasters. That, as we have found, can be explained by the laws of physics. The greatest paradox is why we stopped doing it. We are a species that has learned to predict the weather on Mars, but cannot hear the earth cracking beneath our own feet. We have built houses so strong, walls so high, that we have ceased to feel its warning tremors. We have become too confident in our instruments and have completely forgotten how to trust our instincts. We have become so engrossed in creating an artificial world that we have become deaf to the real world. And now, we send satellites into space to hear what any toad in a roadside ditch can hear without any effort at all, the roar of our own planet, to which we have made ourselves deaf. And now, a question for you. Imagine you live in a seismically active zone. Which signal would you bet your life on? On one hand, a cold, emotionless report from a seismological station, full of graphs stating probability of event 15%. On the other, the sudden, ringing silence in the forest, empty nests, and the mass, inexplicable flight of all the animals around you, the panicked flight of life itself. What would you bet your life on? The precision of a silicon chip, or the wisdom encoded in DNA over millions of years of evolution? Write your answer in the comments.